Everybody else is having it too, so it's not just me.
You're hot.
What? No.
This makes for a very boring video.
Invariant?
Recording.
Is that says invariant?
Yeah.
Invariant line, yes. With 2 eyes with dots.
Thank you.
You're welcome. Are you not bothered by a T crossed completely or only partially?
It does, but I'm not going to make you rewrite it.
I could just do that.
Where's shear?
That's better.
Your rotation eye doesn't have an eye dot.
At least you know it's a T and an I. Lots of
And
people.
the direction.
I just should have not done it. It's true though, I must have a thing of
Your
only
direction
dotting
T
one.
doesn't have a line through it.
But it sort of does.
Where?
Now it does.
And that's like an R.
Isn't it difficult to write on that thing?
Not for me, for you it would be.
Like
Yeah,
that just
you
like
can't
how do
even
you?
see things. That's
yeah.
when you go to get your license, they make you sign your signature and you can't even see what you're writing and you're like,
Yeah.
whoops.
My signature cannot really bad.
Just saying, I cannot see anything.
Okay, well it's just practice because I don't know whether you've ever done this, but for whatever reason when I was younger I used to practice writing with my eyes shut to see what it'd come out like. I found I'm alright at that. I must have reasonable hand-eye coordination. Right, anyway, let's just go through. Let's discuss what happens to specific points. That'll please Cassie. What happens when you reflect a point? So, when I say a point, let's talk about its coordinates. Alright, so we're talking reflection, and I've got a point. Let's say the point is at 2, 3. That's point A. What would be the coordinates if I reflected? We're going to keep it simple. If I reflect in the y-axis, what happens?
-2, -3, -3.
Have a think. So visualise, what do you think? I'm not going to draw it for you, you need to be able to visualise. So imagine a set of axes in your head, you've got 2, 3. Where does it end up if I reflect it in the y-axis?
-3, 2. -3, -2.
What?
-2, 3.
-3, 2 if I reflect in the y-axis.
No,
I need to
-2, 3.
No, it would be 2.
-3, -2.
Which one's the y-axis?
-2.
This
one.
I don't know.
That one.
Wouldn't
You
it
don't
be -2, -3?
No,
Yeah.
-2, 3.
I don't know.
Yes,
How is say +3? How is that +3?
because
Oh,
if
yes.
it just flips to the other side. The y, if I reflect in the y-axis, the y coordinate doesn't change, does it? Alright. What about if I reflect it in the x-axis? A dash would become,
2, -3.
okay. Now what do you notice then about which coordinates change?
The opposite one of the axis.
Okay, so in this case, we're talking reflection, and if it's the y-axis, it's the x coordinates that's changed. If we reflect in the x-axis, it's the y coordinate that's changed. That's a horrible colour for the screen. So this is what I want you to start thinking about. This is the way we think of translating points. It's like that will happen for every single point on the function, right? It doesn't apply different things to different points. It does whatever it does. So all I need to think about, if I'm translating a function and I know I've got a reflection in the y-axis, all the y coordinates will stay exactly the same, but the x coordinates will change. Alright, and how did it change? If the x coordinate changes, it just changed. Did the number change? It just became negative. Alright? And if I reflect in the y-axis, the x coordinates don't change, the y coordinate just becomes negative. Now, we can reflect that, we can show that in our function notation, and this is what I would like you to be able to read when you're doing function notation, transformations of functions. Okay. Before we go on to that, let's talk about translation then. So if I have a point 3, 8, and I translate, and I do it, well, how would you apply a translation? So if I call it x and y, what would the new coordinate, so if coordinate b, what would b dash be? Do you recognise the dash for the image of the original point? You see I've done that, so a and a dash. A is the object, this is the image of the point after the transformation. So where would b end up?
3 plus x.
Okay, so it'd be 3 plus x,
8 plus y.
8 plus y. Okay, so we affect the coordinates in that way. So again, we want to be able to think about how I do that with transformations of functions, with the function itself. Right, do we ever rotate a function really?
No.
No, we're not at this point. We're not talking about rotation, so we don't need to worry about our rotation. We're reflecting in different lines. All right. I need to talk about reflection again. Enlargement, we also don't tend to do in one go. We do stretches. All right. So stretch would be in one direction or the other. Yeah. So let's say again, say I've got point C, let's say that point is at 1, 8. What if I want to do a stretch, scale factor 2 in the x direction? What would happen to the coordinates? So if you think about the shapes that you did it for, like a rectangle or a triangle or whatever, how do you apply that? What would that single coordinate, where would it end up? So a stretch of scale factor 2 in the x direction. Where would C dash end up? Do you remember your stretches, or you all kind of like don't remember stretches at all? No? Just try this. So I'll just draw some axes. So here's a point. I'll change it. So we've got 4 and 4, and then let's add a couple more points. So do you notice how my rectangle is just 4 individual points? Well, actually it's an infinite number of points. It actually is a square. It looks like a rectangle from it, but a square is a rectangle. So what does that look like if I do a stretch? A square is a rectangle is not necessarily a square.
I think so. Yeah.
I swear a rectangle has to have one. Okay, never mind.
So definition of a rectangle: 4 sides, 2 sets of parallel sides, 4 90-degree angles. And a square meets all those criteria.
So why didn't you just teach me when I was a kid that squares were rectangles?
They did, you've just forgot.
No, they told me it was a different shape entirely. There's a rectangle, and then there's a square, and then there's a triangle, and then there's a circle. That's it.
Your life must be so simple, it'd be great.
I don't like this. This math.
So do you have scooters and motorcycles, or they're all just bikes?
No, they're all just bikes, but like they're different types of
Like a
bikes.
different
There you
brand.
go. Different types of rectangles.
No, they're all shapes, but they're different type of shapes.
Anyway, this is going to mess you up even more. So a rhombus is a parallelogram, but a parallelogram might not be a rhombus.
Huh? I don't even know what
They don't
this
even
is.
have
Oh,
the
rhombus
lines.
is this.
A rhombus is a
Diamond.
kite.
No, it's not.
No.
I mean,
A kite's a kite. Anyway, how do we apply? Let's do a stretch at scale factor 2 in the x direction. How do we do that? So we're applying it in this direction. Oh, that was good, wasn't it? We're applying it in the x direction. Okay, and how do we do that?
Find 2 more little dot spaces.
Okay, so the way we do it is we look at which line is invariant, the y line. So what we do is we go back to that and we figure out how far away we are from the y-axis. Now, how far we are away from the y-axis is the x coordinate. Do you realise that? So when x is 0, you're on the y-axis. So if I've got 4 as an x coordinate, I am 4 away. Alright? So what do I do to that? Well, my new point is 4 times the scale factor, so 2. So this point here, if I say that's point C, C dash will be 8. Okay, so it will be at 8. Now what is the y coordinate? 4. So what will the y coordinate be on the new one? 4. So if I apply that, so that will end up at this point.
But how do you draw it? Because that's not even complete.
Okay, well this point we'll do exactly the same thing because it's also 4 and we don't change the y coordinate. This point is how far away? 4, 5, 6, 7. So that will end up being how far away? 14. So we have to go 7 and another 7. So that will be there and this point will follow that. So my new rectangle, it's definitely a rectangle now, will be like that. So when you apply a stretch, not only do you just stretch the shape, but you actually move it away from the y-axis as well.
So we don't have to connect the original fourth well.
No, because this is let's say shape A and this is shape B. This is the stretched shape. Yeah. So there's no connecting to be done. It's quite nice if you see an animation where if you move the shape. So if I were to move this shape closer, alright, it would change this stretch, alright, or its position. If I move this shape further away, this shape will move even further away. Okay, but the size of it will remain the same because every length is also doubled. Yeah. Now, when we talk functions, however, we're only really looking at our individual points and what happens. So what has happened to the coordinate, the individual coordinate, which one has changed of a stretch, scale factor 2 in the x direction, which coordinate changed? Which one, x or y?
X.
The x coordinate changed. By how much? Scale factor of 2. Yeah. So if we go back up here, look. So if I've got a stretch invariant line, so scale factor 2 invariant line y, so x direction, what would the new coordinate be? So it'd be 2, 8, wouldn't it? Remember, the y didn't change. It just shifted everything that way. So it was the x coordinate. How could I do it? Just generically. So if I've got x and y, what would the new coordinate be?
2xy.
2xy. Okay. So that would be a stretch. What if it was a stretch in the y direction? The x, 2y. Okay. Okay. So that's how we need to think about it as individual points and what happens to each coordinate. Let's now have a look at, in the textbook, so on page 22, right? let's have a look at the function notation. Let's see whether we can get the same principle. Right? So, if I have a function of x, all right, what is f of x also known as? Y. Right? So if we focus on that, f of x is also y. So if I have the x coordinate, the f of x gives me the y coordinate. So I can think of it like that. So if it says, if I do f of x plus k, it tells me it's a translation. Alright? But can you see why? What is happening? Which coordinate am I affecting? Am I affecting the x coordinate or the y coordinate? The y coordinate. So I know, using this notation, I am taking the y coordinate and adding k to it. So the coordinate, if the original coordinate was xy, the new coordinate would be x, y plus k. Alright? So what I am doing, I'm working outside of the function. So I'm doing it after the function has been done, so that affects the y coordinate. Right. So I can look at it and go, right, so if I want to know what f of x plus k does, the x coordinates don't change, but all the y coordinates shift up by the same amount. Alright, they all change plus k. So what would that do to your function? Okay. Move it up. If every point just added k, you'd shift the function up. So like if I took a rectangle, if I added k to every single coordinate that made up the rectangle would shift up, yeah? So what kind of transformation is this? So that would be a translation. Alright? What would the vector be?
0.
Good. 0. Okay. Does that make sense? So it might not be quite the way they're talking about it in the book, but it's a nice way to think about it. Is if you can actually identify which coordinates are being changed, when they start getting more complex, it'll make more sense. So what will f of x minus k do then? Shift it down. So it's a translation. So the y coordinates, so the coordinate of any point will end up being x and then y minus k. So it will shift it down. Alright. Now, I'm going to change the order in which they're doing it in the book a little bit. Do you want to write that down at all at the moment, or are you happy that it's in your textbook and we'll just carry on? I'll get my talking done and then you can start doing some questions. Right. Talk about this inside and outside of the function. I'm going to do the other ones that are outside of the function. So what if I were to do k f of x? So we take an x and y coordinate. What will it end up being? Which coordinate gets changed? The y coordinate, because we're outside the function. And how will it be changed? Yeah. So the new coordinates would be x and ky. So if I take every y coordinate and I multiply it by something, what is that going to do? Yeah. So this will end up being a stretch. And what will the scale factor be? K. And it will be direction y-axis. Okay. Now can you see why the x-axis would be invariant now? Because if the coordinate, if the point was on the x-axis, what would the y-coordinate be?
0.
0. And if I had 0 for the y coordinate, k times 0 would still always be
0.
0. Hence, if a point is on the x-axis, it will never move if I multiply it. It will move if I add or subtract. Okay, what about minus f of x? So think about it. Which coordinate gets changed again?
Y.
The y coordinate, and how?
Times negatively.
So it becomes
Negative.
Negative Y.
negative y. So what's that?
Stretch.
A reflection.
A reflection, isn't it? A reflection in what?
The Y. X-axis.
The x-axis, isn't it? The x coordinate stays the same. It becomes a negative y. Okay. Okay, is there anything else where we just affect the y coordinate on its own? You think about it. Obviously, I can combine all of those, can't I? So, yeah, exactly. If I was trying to be mean and challenge you and make you into the supreme mathematicians that you're all going to be. So, for instance, I'm writing here. So, what if I were to do minus 2 f of x plus 3? And I asked you, what would be happening to that function?
Well, it's going down. The Y is going down. By.
When you say going down, what do you mean?
Well, the negative makes it reflect, right?
Okay,
And then the
so
2
all the y coordinates would
reflect.
become negative.
And then it's
Then they would be
and then is it a,
multiplied by 2,
stretch.
so that would be stretched.
and then it's plusing 3, which would be a translation up.
Yeah?
I don't like that.
But it's just taking it step by step, isn't it? Yeah? So we just read it in that way. I know, because everything is outside of the function. Do you get this outside of the function thing now?
Yeah.
Yeah, we're outside of that x. We're not affecting x. We're only affecting all the y coordinates. So I can look at that now and go, all right, so what happens to my y coordinates? Well, they all become negative. Then they get multiplied by 2. So the closer I am to an axis, you know, the less effect it has. And then if I add 3, it shifts it up or down. All right? So then suddenly it doesn't become such a big issue to think, well, what would happen? All right? We just think of all those individual little points. And again, that's why if I think of a line as lots of individual points, it makes more sense that all the points are doing that. If you have to do it to a line, even I, visually in my head, I'm thinking, how do I multiply a line by 2? I can't. It doesn't make any sense. But if I multiply every single point, their y coordinate by 2, that's perfectly, every point goes up, and that makes the line go up. But so it's just a way of thinking. Okay, so I've only affected the y coordinates. What do you think comes next? All the same stuff, but inside the function. Okay, so let's talk inside the function, and we've got to think a little bit more about this one. Okay, so now we're affecting the x coordinate. Alright, so we'll do it in the same order. What do you think f of x plus k will do?
Y. X plus K. What's the translation?
Sorry. So, it makes sense that it's going to be a translation, yeah? But what will the coordinates be?
Oh, X plus KY. Right.
Okay.
Okay. So never mind.
I've just not written it yet. It's not quite as simple.
Of course it is.
Well,
What will the new coordinates be?
I mean, because wouldn't that affect y? No?
Well, sort of. Depends on how you want to think of it.
No. You like it first. Didn't you?
Now I could just say to you, alright, you will probably remember something about this. Okay. Alright. So it is, we know, a translation. Okay. The new coordinates are going to be, right, well, we've got to think it through a little bit more. So what I'm going to do is let's actually draw this and see what happens. Okay, I've got to explain this one to you because it's not quite so simple as the y coordinates. And do you know why? Could you sort of have a guess why changing the x is a little bit more of an involved process than just changing the y? No idea? Well, what has already happened when I change the y coordinate?
The x is already on like plotted.
Well, yeah, so what has happened? What have I already done? I've taken the x value and already done the function. What am I doing if I change the x coordinate?
Changing the function.
Well, I'm not changing the function, but I'm changing the value before I put it into the function, and therefore, I think like Courtney said, it will affect the y coordinate, sort of. Yeah? So, we've got to think about this then. So, what will actually happen? What I'm going to do is I'm going to draw a function that you'll recognise.
Do you have to like minus it from the y?
Well, let's have a look at something. So do you recognise this function? Okay, so the function is basically, well, that's 0, 0, 1, 1, 2, 4. So it's f of x equals x squared. Okay. Now what happens if, now you've seen this before, if I do x plus 3. So it becomes, the new function becomes x plus 3 squared, yeah? Alright. Now, what does that look like? So what we have to do, we have to think of it. You're going to end up with a nice, simple thing to take with you and to apply. But maybe to understand it, which is what I'm hoping you'll do, it'll be a bit like, oh, what? So, for instance, if I want to know my new function, what I'm going to do is I'm going to pick some values of x and y, and I'm going to draw my little table out, which you've probably done a long time ago. Alright, so this one I've got those values, but what if I redo it? So I've got minus 2, minus 1, 0, 1 and 2. So what will the values be for these values of this function? So I put it, so minus 2 plus 1, sorry, plus 3 is 1. 1 squared is 1. Okay. Minus 1 plus 3 is
2.
2 squared is 0.
3. 25.
Okay. Alright. So what's happening? So if I now plot this point, minus 2 here has a value of 1. Okay. Minus 1 has a value of 4. Okay. No. See, what I'd have to do is go, well, what about minus 3? Zero. What about minus 4?
1.
1.
Oh.
Minus 5 would be 4. Okay, so what actually happens is,
Why do you know?
okay, so it is a translation, but in which direction?
Negative.
Negative. Okay. So this is how I try and explain this to you. So when I want to know what happens when I have x plus 3, basically what I do is I think, right, for the function that I want, I actually have to, instead of thinking the plus 3 is where I move it, I think the plus 3 is where I look to take the value that I want for my point. Does that make sense? So if I want fx plus 3 of minus 2, I've got to look at add 3 onto the x, and I take that y value and I bring it back to where I want it. Does that sort of make sense? So f of minus 1, if I want to know what this is, I have to go minus 1, but I've got to add 3 to the x to figure out the y value and bring it back to my x value. So put minus 1 in, I add 3 to the x. Now I'm not changing the x, I'm kind of saying, well, if you want to know the y value, you've got to add 3 on to find the y value and then plot it, because that's the x value. Does that make sense? So x is minus 1, so it's going to be on this line. That's where I'm going to have to plot it. Alright? So if I think of it like that, so I know that if x is minus 1, it's going to be on that line. Sorry, that wasn't very clever. So it's going to be on there, and what do? Well, to find that point, I have to go to 3 to where the initial function was, find the y value that goes with it, and bring it back and plot it on my x value. So what is actually happening to the function? It's actually coming back. So it's the opposite of what you think it would be. So if I have f of x plus k, alright, it is a translation, but what has actually happened to the coordinates? Well, it will actually be x minus k.
Why did you just, I would have got that if you would have said that.
Yes, but like I said, I could have just told you, but I wanted you to have, I want to at least have some go at trying to explain why it is happening. I'm sure you've been told before, in fact, I think with the quadratics, you've been told, oh, if I add it on, it goes left. If I'm sure you've been told that before. I just wanted to have a go at trying to explain what it is. So with the x coordinate, it seems like when I do a translation, the opposite's happening. Okay, so I actually have a translation. What would be the vector for the translation? Minus k, 0. Okay. Alright. So if I then, we look at the other one. So if I said to you, what does f of x minus k do? So x, y, the new coordinates would be x plus k, y. And it's a translation. What's the vector again? K0. Alright. Now this is generalized. in this way, and maybe you can explain why it's generalized in this way. So actually the general form will be written as simply f of x plus k is always minus k0, and we use that for whether it's plus or minus. Can you understand how they can use that single form?
If it's too negative, like a positive.
Okay, so what we say is f of x plus k, it's almost like, I think we've discussed before, there is no subtraction, there's only adding negative numbers. So if I add a negative k, it's like subtracting k. Alright, so that's the general form that we use. Right, let's have a think then about what about f of minus x? Might be a bit simpler to think. So xy becomes think negative x, y, does that work? The x ones are definitely more, but is that alright? If I just take the x coordinate, can I just make them negative and the y coordinate stays the same?
Yeah, sure.
Yeah? That would be a what then? Reflection in
Y-axis.
the y-axis. Now let's just check then. So if I've got f of x equals 3x plus 2, what would f of minus x? It should be a reflection in the y-axis. So what would it become? 3 times minus x plus 2, and that ends up being? Now, is that a reflection in the y-axis? Straight line. It's difficult to visualize, isn't it, after a bit of practice. Shall we have a look? Do you know how to draw your 3x plus 2 without having to plot all the points? Yes, no? No? What can I tell about that line, 3x plus 2? Okay, so crosses at 2. So let's say each square. So I'm going to cross at 2 and the gradient's 3. So the next point would be at 3, 4, 5 now. Then it would be 6, 7, 8, like that. Happy with that? So if I do that, so that's the first one, 3x plus 2. What would the other one be? 3x plus minus 3x plus 2. So it still crosses at 2, but the gradient is minus 3. So would that not go cross 1 down 3? Cross 1 down 3. Go the other way up 3. What do you reckon? Is it a reflection in the y-axis?
Yeah.
Yeah. So that's lucky then, that was a bit easier. Okay. And finally, what's the final one that we need to consider then?
A stretch.
Okay. So let's do f of what is left with just the x inside the function. Do you want me to put it back up, Connie? So have a think. What do you think f of kx does? So xy becomes you've all gone kind of, oh, I don't know, because he really messed us up doing the translations and it's all going to be much harder. But it's not really, is it? So, what's you trying me to? What's the new x coordinate going to be?
X over K.
X over k. Kxy, do we think?
Yeah.
Oh, it's reflections, not translations. Oh, what?
Have a look. Have a look at your stretches. So it's similar to what the problem with the translation was.
1 over X.
Okay.
I was kind of close with my.
Yeah, you were. Not quite 1 over x, is it?
1 over K.
1 over Q.
Well, we've not. It's 1 over k x. And it's the same thing. So if I want to know what to do, so my x value that I want, I have to multiply that, go and find my point and bring it back. So that's the difference again. This one is another, annoying one. Right, so it doesn't just do it to the x. It's like, okay, I want x is 1, I want to know where the point is, but if my scale factor is 5, I've got to go from 1 up to 5, find what the y coordinate is, and bring it back to the 1. So that will actually bring the graph in. Alright? And the reason why it's a stretch and not a translation is because if this time, if I go to the negative side, I'm at -1, I have to go to -5 and bring it in. So imagine I'm going out, finding my y values and bringing them back in. It shrinks it. Yeah. Now, that's what a lot of people get confused with in this, in a stretch in the x direction, because what would a stretch in the x direction actually look like? So for instance, my initial function could be like this. Ooh, I'm just guessing now. Alright, but like I said, what would happen is, if I wanted to know this point, it stays the same, but if I want to know here, I have to go there and bring it, so that would come back and that would be my new point, do the same in that direction, and so on. Does that make sense? So what would actually happen is this, looking at quadratic, right, say it again.
How do you write an X in cursive? I'm sorry, I've been thinking about this whole math lesson.
In cursive? What's cursive?
Like when they go like this, and like below.
Okay.
Like right after.
Oh yeah, it was kind of like it's kind of got a funny squiggle on the end. Connection.
And then you just have to make the other line.
Yeah.
I just make this.
Right. What does that look like? Might have happened though.
It
shrunk. Yeah.
Well, would you be able to tell the difference between whether I have gone from that point up or whether I've gone from that point in?
Not really.
Just looking at it.
Oh wait, kind of.
Because this point, I could have said, well, I've stretched it in that direction to go up there, or I could say, well, I've taken this point and brought it in. So
I don't know which one.
How about you done both?
no. But it could look like the same thing, yeah? So it could be either or. So we need to be careful, I guess. Alright. Well, depending on which one you get told it is. Okay. Right. Let's have a quick check on, see how much you've understood then. So if I then said, what is happening to?
So what was that stretch in? What axis?
Oh, so this one would be a stretch in the
Y?
X.
x direction, wouldn't it?
The x direct and the scale factor is
1 over k.
okay.
Yeah.
That's right.
So we've got stretch, x direction, scale factor 1 over whatever the k is. So if I said to you, we've got minus 2f of x minus 3 plus 2.
Does that minus 2 go for the y?
So it's outside the function, isn't it? And then, what would happen if I said to you, what's happened? Different one. So what's happening here and what's happening here?
That one y.
Say it again.
That one's more. That one's
They're both very, very similar.
Thank you, Mr. Potts.
Thank you. So what's happening with this one? All the stuff.
I'm translation.
So we go translation,
Reflection. Stretch.
so our translation goes in what way? So we should have a vector for our translation.
Plus 2. I mean, maybe 2. Up to.
Up to, so that's a 2 on the bottom, yeah?
Yeah. And a 0.
No, because I've also got
plus 3.
plus 3, isn't it? Because that's a minus 3, so I know the translation's that way. The reflection is in
The y-axis.
the y-axis, you sure?
Yeah. Yeah.
Why? Because isn't this outside?
Value.
So it's in the x-axis, isn't it? Because all the y-coordinates get made negative. So that's reflection in the x-axis. And then the stretch is scale factor 2, direction so it's outside, so all the y-coordinates, so it's in the y direction. Now do you notice how a reflection and a stretch could actually have gone together? So could it not be a stretch of scale factor minus 2?
Could be, but I don't think like that.
Up to you. Right, so if I told you that g of x is this, what would be the initial function and how has it been translated? So if I tell you g of x is f of x having been translated, what would you say has happened? What's the original function potentially? It might not be, but if I said it's a simple one, what would the initial function be? So let's start with f of x could have been, say what you see. No, like what is the initial function with no transformations applied to it? It could be, but even easier to spot. So what are all the additions that we think have happened? So I would go with a plus 1 has happened, a minus 4 has happened outside, and a times 3 has happened. So that leaves me with x squared, no? So that's my base function. And then what has happened in function notation? So I've got f of x plus 1
1
times 3 and minus 4. And that would be equal to g of x. So what I've done here is I've given g of x in terms of f of x.
Wait, so why isn't it x minus 1?
Right, that would be what would happen,
Yeah.
but actually in terms of function notation, that's what I would write. Yeah. So I can say that if f of x started life as x squared, g of x is equal to 3f of x plus 1 minus 4. Sorry. Alright, you see how it's building up. And what has happened to x squared?
It's just saying that it's a quadratic.
No, what's happened to it? What transformations? Stretch? Which direction? Up, so that's in the
Positive.
y direction. It's been translated. Oh, it's been translated down 4 and
Up by 1. Moved across
which way?
negatively.
Left
Left of 1.
1. So we've got a translation, left 1, down 4, then stretched in the y direction with a scale factor of 3. Alright?
So if it's down 4, then we could in the factor be minus 4.
Exactly, yeah.
And then if it's left, it's
Minus.
positive 1. But then if it's in the positive direction, it's minus 1.
Yeah. Lots there. We did it all in one go. I tell you what to do. Make sure you review those pages there. Alright? Have a read of it. And in their examples, it might help clear some stuff up for you. The questions I've just given you, feel free to have a look. Some of them are easier than others. If you want to have a go at a couple, but bring these with you next time, and then we can start going through them. If you do them all and want to know the answers and want some more, just email me and I'll have some more ready for you next time.